Okay, we're starting chapter 7. Chapter 7 notes packet. Here we're talking about exponential growth and decay. So my formula for this thing is y equals a times b to the power of x. That's the formula that goes for growth or decay. Growth happens when a is greater than 0 and b is greater than 1. And b is the growth factor. Decay happens, a is always greater than 0, but this time b is less than 1. And this time b would be my decay factor. So growth happens like this. It just keeps getting bigger and bigger. And actually my y-intercept happens at 0, a. Decay goes the opposite way. It goes down. But same thing here. Y-intercept is still 0, a. With my domain being all real numbers. And range, you kind of have to look at the graph. In this case, since these are both positive, that means it's bigger than 0. So let's do a couple examples. Zoom in here. There we go. So graphing this thing, my domain is going to be all real numbers. My range, y greater than 0, because I have nothing happening after this. So I just set up an XY chart. 0, 1, 2. When I plug in 0, 2 to the power of 0 is 1. 1, 2 to the power of 1, 2 to the power of 2. So that when I graph this, it just gets bigger and grows. Let's do the second one. Domain, all real numbers. Range, y is greater than 0 because I have nothing going on after this. We'll talk about that a little bit more tomorrow. When I set up my XY chart, I forgot in that last one I want to include -1, 0, 1, and 2. So that when I plug in like this, -1, 4 to the -1, if I go into my calculator here, where is it easy to see? There we go. 4 to the, that's 1. 4 to the power of -1 is 0.25, and then I times it by 0.5, gives me 0.125. 4 to the power of 0 times 0.5 gives me 0.5. 4 to the power of 1 times 0.5 gives me 2. And 4 squared times 0.5 gives me 8. So that when I plug this in, -1, 0, 1, 1, 2, 2, 8, all the way up here, it just grows nice and big. Next, we're talking about word problems here with growth or decay. So the growth has a plus here, decay has a minus. A is your initial amount. R is my rate, and that's a percentage. And then T is my time. And in this case, that is my variable. Now, I actually looked this up a little while ago. Hold on. I looked up the current U.S. population and found out that it was 318.9 million. And our growth rate, according to Google, is 1.11%. So write a model to represent the growth. So I'm doing this formula here. So my initial amount is 318.9. Then I have 1 plus my percentage. I need to move it 2 decimal places. So 0.0111 to the power of t. And I'm just going to simplify that. 318.9, if I add these two together, 1.0111 to the power of t. So that now when I want to estimate the population in 2020, that's 2 years away because it is currently 2018. So I'd do 318.9, 1.0111 to the power of 2. And at that point, I'm just plugging it into my calculator. 318.9, 1.0111 squared. And just like that, there we go. Gives me 326.01 million. There you go. Next one says a new jet ski costs, and I looked this up on Google too, $2,500, and it decreases by 10% each year. So this one is my decay model, exponential decay model. So I have my initial amount, 2,500, 1 minus my percentage is 0.1 if I move that decimal place over to the power of t. So that'd be 2,500, and then that's 0.9 to the power of t. Estimate the value after 3 years. So I just plug it in, 2,500, 0.9 to the power of 3. Gives me 1822.5. E is just a number. It's kind of like pi, where it's like 3.14159, blah, 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 keeps going on forever. E is 2.718281828, and it kind of just keeps going on forever. So it's another number like that. So we're going to do some stuff with E. So we're going to simplify first. When we multiply these, what do we do to their exponents? We add them. So same thing here, 2 times -6 is -12, E10, because I add them. Here this gets distributed, so it's 5 squared and E -6x. And then so 5 squared is so 25, E -6x. And what do we do when we have a negative exponent? It goes on the bottom of that thing, we flip it. So this is actually going to be 25 over E to the 6x. Over here, I'm going to distribute this in first, so that would be 2 to the 4th, E to the 4x. 2 to the 4th power is 16 times 3, gives me 48. When I'm dividing, I divide my numbers first. 12 divided by 3 gives me 4, and then I subtract my exponents. So 10 minus 5 gives me 5. Same thing over here. Divide these first. If I divide them, I can take out a 2. And then same thing with these. Subtract them becomes negative, so it becomes on the bottom. Last part for this is in your calculator. So in your calculator, let's see if we can zoom in here and see this. There should be an ln button on your calculator. ln, can you see that? And then right above it is e to the power of x. That's the button we're talking about. So we're going to go second e to the power of 4, because that's what the first one wants. 54.59. Next one says e to the power of negative 0.09. Becomes 0.91. And this one, we want to put it in parentheses here. So we have 2e to the power of 3. So that's like 2 to the 3, e to the 3, plus 1. So 2 to the 3rd, and then e to the 3rd, plus 1, becomes 161.68. There's day 1.